Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When a 1-ω-dihalide, a dihalide with halogens on both ends of a carbon chain, is treated with zinc dust, an intramolecular dehalogenation, Reformatsky-type ring closure, occurs, forming a cyclic hydrocarbon. This reaction is known as the friend reaction. Moving on to the next step. Identify the reagent and substrate. 1,3-dibromopropane is BrCH to CH to CH to Br. Bromine atoms are on C1 and C3 separated by one carbon, C2. Moving on to the next step. Reaction with zinc dust. Zinc acts as a reducing metal that abstracts both bromine atoms simultaneously or in a concerted-like fashion, forming a zinc dibromide, ZnBr2, as a byproduct and creating a new C bond between C1 and C3. And for the final step, the new C bond between C1 and C3 closes the 3-carbon chain into a 3-membered ring, yielding cyclopropane. Overall, BrCH to CH to CH to Br plus Zn cyclopropane plus ZnBr2. Why other options fail? A. Propene would require elimination of HBr, one bromine and one hydrogen, not both bromines. This would need a base, not Zn dust. B. Propane would require full reduction of both C-Br bonds to CH, which needs a stronger reducing agent, example, H2 catalyst or Lyell-4, not simply Zn dust. D. 3-bromopropane would mean only one bromine is removed, which is not the typical outcome of Zn dust with a 1,3-dihalide under these conditions. Therefore, the correct answer is C. Therefore, the correct answer is option C.